Hello everyone, welcome back to lesson 2 of this introduction to coding. If you have not watched the first lesson, I would highly recommend you go and do that, because of order and stuff, but also to get yourself set up in what we're going to be doing. If not, it's not a big deal at the moment. You're not going to need Visual Studio or anything really for what we're doing today, but definitely for the next lesson you will, so make sure you go back and watch that and follow the instructions there. So last lesson we sort of described a little bit about what is programming and what it's for and the general gist of how it works. And today we're going to be diving a little bit further into that. So we're not actually going to be doing any coding just yet. It's really important that you understand firstly how it works and how you fit things together rather than actually trying to write something and not understand it too much. So I've just put some lovely code on the screen. Feel free to figure it out. It's fairly simple code. Big smile on my face. But we'll see how we go. In the next lesson, we'll definitely be writing something called the Hello World, which I've described a little bit before. But today, we're going to talk about some things. Firstly, languages and what they are, some examples of languages, and just sort of how the knowledge transfers between them. IDEs, or integrated development environments, compilers, frameworks, and other tools. So, and why we actually use some of these tools over some other things, and why you use certain languages over other ones, and stuff like that. So the first thing we'll talk about is languages. Now, the primary language of this series is going to be English, obviously, but also C++. Now, C++ is one programming language. It is a subset of a programming language called C, and there are some other very closely related cousins of C# and Objective-C. If you've done any kind of coding on iOS, you would definitely have used Objective-C most likely, because that is mainly an iOS one. If you've done any programming on Windows, which, to be honest, if you've done any programming, you definitely shouldn't be watching me. You would have done some kind of C programming most likely. Now, that's just my personal preference. I definitely prefer the C family of languages because that's what I've been taught. It's a lot closer to the CPU and a lot closer to the processor than some other languages, and I'll explain that as we go on a little bit further. But also it's the most, I won't say the most difficult to learn, but it's definitely the one with the most concepts in it that you have to learn. A lot of the other languages will hold your hand, and C++ is more of a sort of let you fall over kind of language. So if you're learning C++, the amount of knowledge you have to transfer between other languages is very high. Whereas if you're going from another language like Ruby and Python, which I will show you in a second, you have to learn a lot on C++, especially in like the basic concepts of it, to really understand what's going on. It's not quite as simple. And that's not a dig, that's just how they're designed. So let's just have a quick squiz at a couple of languages. Let's just talk about. This is Python. It's very pretty. It has some really cool things. I've never really used it, but I have used its very closely related cousin Ruby, which I believe is not a subset of Python, but it's like based on it kind of a little bit. Like it's really hard to trace the lineage of some of these languages. People will just get bored and write their own languages for no reason. Some write languages just to solve a certain problem, and then other people can apply that solution to their problem. But the basic differences in languages are what's called syntax. Now, if you've ever been multilingual or learnt another language, you would have learnt the difference, like, say, Italian. Italian has, if I'm remembering correctly, feminine and masculine words. So, like, boy and girl are just a variation of one word with a different letter at the end. That is the syntax of the language. If I'm remembering correctly, don't hold me to that. Whereas some of these words here are the syntax of C++, like int and return, and the double quotes here. They're all syntaxes of the language itself, whereas something like Ruby, yeah, look, it has double quotes. Do they relate? They are. They're exactly the same thing. But they don't have certain other things that the languages like C++ do. Same with Python. It changed the example on me. They use single quotes instead of double quotes. So it is a tiny little bit different, and it's close enough that you can go, oh no, okay, I'll just switch that around in my head and everything else is kind of the same. So that is a very big advantage of learning something like, as I said, like C++. You have a lot of knowledge to learn, and it will take longer. It will be a lot harder to understand, but once you understand C++, you can basically program in any language. Now, I'm not saying you can't do it backwards, but this is the way I preferred to learn, just from personal experience and personal preference. Feel free to try another one. That's up to you. You might get a little bit quicker, a little bit better, a little bit quicker on other languages, but then you don't really get some of the base concepts of how a program actually works. So that's languages. Let's talk about IDEs. So IDEs, before, as I said, is integrated development environment. Visual Studio is one of those, which I would have told you to download in the last episode. If you haven't, I'd recommend starting it. It's like an 8-something gig download or even bigger. So definitely do that if you're on a shitty connection like I was at one stage, not anymore. So another couple of examples of IDEs are Sea Lion, made by the extremely talented people at JetBrains. Now, I say they're talented, and they really are, but it's not really my thing. I've used their Ruby IDE, because you can get IDEs for different languages. They do different things. Excuse me. But I'm not a fan of the C one versus Visual Studio. But that's, once again, personal preference. Once you learn the basics, you can try all of them and see which one works best for you. It won't really make a difference to your programming ability after you've learnt, but because we're going to be learning the basic concept in something new, if you want to follow along, you should probably use Visual Studio. Another one here is Eclipse. Now this one is primarily, at least was when I last used it, for Java, but when I used it about 12 years ago, it fucking sucked. It was so bad. That might be different. I'm not sure, but that's just my opinion on that one. So we'll flick back over to Visual Studio. So those are your IDEs. Now, why do we use an IDE over, say, Notepad, which I can show you right here with this little bit of code. Here, I'm going to go into Notepad++. It's the exact same file I got open. It's just a text file. I can modify this to say, hello, and save it, and flick back over here, and it's updated. It's no different programming in Notepad++, Notepad, Visual Studio, from a pure inputting the words kind of thing. Where it differs, and if I open this file in Notepad, I can sort of go through the steps. Look at this, flat black text. There's nothing really to Notepad, that's all it is. It's just a plain text editor. We go to Notepad++ and you notice some colors. This is called syntax highlighting. Syntax highlighting is extremely useful when you're reading hundreds and hundreds and hundreds of lines of code all at once, because you can pick out what things are at a distance and your brain can parse it a little bit quicker. Like greens are comments, this big bold thing is a keyword, this pink one or purple or whatever bloody color it is a data type, the big bold dark blue ones are operators. It's all things that you can immediately see once you know. Now this is good, this is a pretty big step, and you could do some cool things with Notepad++, but you move over to Visual Studio, you notice a few more colors, you'll notice that there's a lot more things around, and unlike Notepad++, which is a text editor at heart, and it does have some cool stuff you can do, it's a text editor in the end. You can run macros, you can run programs, you can do batch scripts and stuff like that. But Visual Studio is made for programming. So all of the things you have here are made for programming and made to make your life easier when you're programming. There are things inbuilt like a plugin mechanism, so you can get really cool plugins for just about anything, for coloring things differently, for making windows different sizes, for all kinds of programming help, auto-filling, commenting. It's awesome, and it's really, really easy to use. So that's why people use IDEs, usually. There are other things, of course, like the compilation steps, which I will get into in a second. They're all automated with Visual Studio and most IDEs. You can do things like breakpoints, which we'll go into in like 8 lessons ahead. And then you can get things like debugging, which is also to do with breakpoints. But once again, we will go into those at a later date because this is very simple. But those are things reasons why you want to use an IDE. As I say, Notepad, completely fine, but you're going to be screwed when it comes to more complex projects. Yes, we're back. So that's why you use certain IDEs for certain things. And as I mentioned, there are IDEs for different languages. But why do you use different languages? In the case of what I do, C++ is extremely good for games because it is very low level. It really runs close to the CPU. Once again, this is stuff that we'll get into a little bit later about how the other languages work, but you can extract a lot more performance out of C++ rather than something like Ruby or Java. Even though you have Minecraft running on Java, it runs like fucking garbage. If it was running on C++, this is Minecraft on Windows 7 at least, you would definitely have a much better performing game. Now, in the case of what I do at work, I do web programming. Now, Microsoft recently released a bunch of really cool tools that you can make web programs in very, very simply in C#. So we're using C#. That is not a hard and fast rule. Web programming, you can use basically anything because unlike a game, you can throw more power at it and people just love doing that, which annoys the shit out of me. People will purposely not optimize things because it's just like, oh, we can just add another one. Well, you could, but why? Another argument. It does not matter. But yeah, that's why C++ was one of my favorites. It's very fiddly at the very least, but you do get a lot more raw performance out of it. At least you can if you use it correctly. It's much like a really high-powered car. You don't really want to thrash it if you don't know how to drive. So let's move on to how a program actually goes from this to something the computer can actually run. The computer itself does not understand this text. The syntax of the language is something made for you, the programmer, to be easy to read. A program that the computer can read will look something like this. Now, this is extremely hard to read, but this is what the computer can understand. This is actual raw CPU instructions. There are people who program in this. This is called assembler or assembly, depending on who you speak to. And you can actually program in this, and people used to, right back in the day when you didn't really have a compiler, or not a compiler, sorry, an interpreter. You would have to program like this, and it would fucking suck. The creation of languages really helped computer science get along because you could do things really rapidly and really quickly. Like this here is 1,528 lines of code that the computer can understand, give or take a bunch of stuff. But on screen, it's closer to 45. So you could imagine the difference in trying to write that and having to remember all the different exact CPU commands that the CPU can recognize. And there are hundreds and hundreds of them. And then you go, oh, well, I'm using Intel CPU now, but if I need to use an AMD CPU, I need to write different instructions. It's not quite that bad, but it can be, especially when you switch over to things like, what are they, FPGAs, and things like the Raspberry Pi, which use slightly different architecture. They have different commands that they understand. Could you imagine trying to remember all that? It would drive you fucking mad. It's not quite as bad with a language. And C++ is one of the ones that are really close to assembler or assembly, but they give you enough abstraction away from that so you can actually parse it really easily in your head and understand what's going on. Languages like Java, Ruby, Python are on the level above that, and they're a lot easier to understand subjectively. I find it a bit more difficult because they really truncate everything and make everything as small as possible, so it's a little bit harder to read for me. But there's a lot less things to read. So as a result, they're more easily understood. So how does it do that? How does it go from this to this? That's where the compilation steps come in. Now, if I remember off the top of my head, there are 3 steps. And this is something I probably should have researched before, but I'm pretty sure I'm correct. You have the preprocessor. That is a C++, not only C++, some other languages have it, but it's mainly in C++. Other languages like Ruby, well, they don't even do these steps, they're really the same. So we'll just stick with C++ for now. You have the preprocessor. So the preprocessor takes these little hashes that we're gonna zoom right up on and on. And it takes those and converts this bit of text into more code. It takes code and makes it more code. And I can show you this by going into this. You'll see there's a lot of blank space in these things, because this is something that you're never meant to read. So let's have a look. No. Yeah. So, man, this is a lot of shit. I really should have gotten to the line that I was looking for before I started this, but that's fine. Come on. Find all in current document, please. Man, that's a lot. Wow. Anyway, this is an extremely large file. Here we go. It's literally like 60,000 lines long. 55,645 lines long from this as a result of those two hashes there. Now, once again, that's something that you really don't want to have to manage yourself. That would be an absolute pain in the ass. The basic gist of what this line of code does is it copies another file in. So if that preprocessor wasn't there, you'd be copying and pasting stuff, and that would suck. So we have that as when you get more into how the code works and how the code flow works, you get to know that certain files need to know about certain other files, and certain bits of code need to know about other bits of code. And this is just a shortcut and much neater way to do it rather than copying and pasting stuff everywhere, which is fantastic. So the preprocessor step takes all this shit from here and makes it into this big, long, 60,000 line long thing with my little bit of code right at the end here, which is like 10 lines, and that's it. It basically strips back the code to what the compiler needs, and that's the next step that happens. The compiler is what turns it into this bit of code here, the assembler. Compilers are far and wide. They have thousands and thousands of different compilers. They're all for different languages and for different processes and different things. For the case of what we're doing, obviously we're using a C++ compiler that is built into Visual Studio, and it builds it on what's called the x86 or the x64 instruction sets. Now that's basically all of the CPUs in desktops and laptops. I can't really think of another one that isn't x64 at this point in time, or x86. Now, you don't have to really know what that means, but the x86 and x64 are the languages that the CPUs use to actually read your instructions, which is what you're looking at here. Now, I know this might sound a little bit confusing. We're jumping between languages and stuff, and I agree. It can be a little bit to get get a handle on. But it's all extremely necessary to learn before you actually code anything, just so you can get a grip on how it actually works. You'll be able to think much more clearly about how to make the computer do what you want it to do if you know how to make it do something. So I'll just quickly run that back again. You have the preprocessor, which does some magic text manipulation. That's what we'll just call it. Then you have the compiler, which converts this into something the computer can actually read. That's the basic thing. And the third thing, which we're not actually using, I guess we are kind of using it at the moment, but we'll go into it a lot further down the line in lesson 6 or 7, is called the linker. Now, the linker is when you go, I want to take a piece of code from over there. Instead of having to actually manually rip that bit of code into your code, you just put a reference to it. Much like telling someone to go to the shops for you and to grab something. You don't want them to actually tell you how they're going to do it. You just want the thing they've gone to the shop for. That is the whole point of the linker. It's giving an instruction to your program without necessarily knowing what that instruction is and how it works, and having to know that. And then having to go, oh yeah, that instruction is in this part of my brain, so poke it right there. And that's how we'll do it. You don't need to know that. The linker takes care of all that for you. And once again, lesson 6 or 7, whatever it is, make much more sense, I can promise you. And that's pretty much it for this one. I'm just looking at my notes. That is a very down and dirty explanation of how a computer actually reads a program, how you as a programmer makes a program that the computer can read. And it can be a little bit overwhelming to understand that. And you might think to yourself, why the fuck is he showing me this before he actually shows me any of the code? He's not showing me how to code and then turning it into something and showing me how that bit of code works. Because you need to think about this stuff. Think of you writing in English, which we technically are, which is why I love these languages, especially like C++. It is very Englishy, and it's very easy for someone who is an English speaker like myself to actually read. And then you think of the compiler and all the steps between you making a program and the computer reading a program as it being translated. I have this problem all the time. I have an Italian grandmother-in-law, and my wife speaks Italian, so I'll tell something to her. She is my compiler. Tell it to the grandmother, and the grandmother will yell at me for something. Cause and effect. It's like programming. And that's basically it. It's a really simple concept, but it's really difficult to get your head around sometimes, and I really hope I've helped explain it. If not, I really recommend going on. In the next one, we'll actually write a program, I promise, and I will try to trace those steps for you so you can see exactly what is happening. And then it will hopefully click a little bit better in your mind. I definitely did struggle with this part a lot in the beginning, especially because I didn't use a language like C++ at my very first thing. It was a little bit more difficult to understand, and I didn't get it for a while. And then I flicked over to this, and then about 6 months into using C++, yes, 6 months, I was a very slow learner, I got it. And ever since then, it just made so much more sense how to write a program that is efficient and that works exactly the way you want it to. Because remember, computers are not smart. Computers are extremely dumb. Only you can make them smart. And to do that, you need to know how to do it. Obviously. That was a really weird sentence, and I'm going to stop yabbering now. I really hope you've enjoyed this lesson. I really hope to see you back for part 3, where we're actually going to write some code. I have missed the clicky-clackety of my keyboard, and we'll hear it next time, I promise, and we will catch you then.